All right, so today we are going to work on 2.2 and 2.3. These involve conditional statements and biconditional statements. We're going to talk about good definitions, all right, and what that means for us. So a conditional statement is a statement in the form of an if-then. That's the structure of it, if-then. Those are the two words. So whenever somebody asks you to write something as a conditional statement, you have to have the words if and then in it. If P, then Q. All right, if P, then Q. P being true indicates Q must be true. Now, it's not the reverse. So if P is false, doesn't necessarily mean Q is false. But if P is true, Q must be true. P is what we're going to consider the hypothesis, hopefully a phrase you've seen before. Q is considered the conclusion. All right. Conditional statements form a foundation of all reasoning. So, in terms of notation, if you read it P then Q, all right, P then Q, and then in a Venn diagram, which you will see, P is considered a subset of Q. All right. If you are a freshman at Southern Regional, then you are a student at Southern Regional, those types of things. Okay? If an animal is a robin, then it is a bird. This is true. All right? Because if we had a circle of birds, and that would be a circle of robins. If an angle measures 130 degrees, then it's obtuse. So remember from last chapter, obtuse angles are any angle greater than 90 and less than 180. So there's all your obtuse angles, and then inside of it is all your 130-degree angles in the world. All right. Now, when writing your own, keep in mind the words if-then form the framework of any good conditional statement. All right? So it's always going to be if and then. All right? So, for example, if vertical angles are angles that share a vertex. If two angles are vertical, angles, then they share a vertex. All right. Dolphins are mammals. Dolphins are subsets of mammals. If an animal is a dolphin, then it is a mammal. Right, so a little scientific application for you. All right. So now for something new but related. The truth value. It's not going to be that challenging. All right. The truth value of a conditional statement is going to be either, what a surprise, true or false. Your job or responsibility is to determine which one. All right. If it is false, you will utilize counterexamples, which were introduced in 2.1. All right, if a number, for example, if a number is divisible by 3, then it is odd. Your counterexample would be 6. Or any number divisible by 6. All right. This is going to be in line with what we call negations. It's adding simply the word not to the statement. All right. So to see it in action, the sky is blue. The negation would be the sky is not blue. when it's in conditional format. All right, with conditionals, what we call the inverse. I-N-V-E-R-S-E, the inverse is created by negating both the hypothesis and the conclusion. So the hypothesis and conclusion are like my two cats at home. If you do it to one, you got to do it to the other. All right? If P, then Q would be transferred into if not P, then not Q. With conditionals, do you think this will always be true? The answer to that is going to be, we're going to find out. All right, now let's look to scramble the order. The converse, C-O-N-V-E-R-S-E, is created by flipping. All right, or reversing the original hypothesis and conclusion. So in symbol format, if P then Q becomes if Q then P. All right. If we combine both the converse and inverse, we have one of my favorite words in the world, the contrapositive. Contrapositive creating by negating. So we're going to add the word not, both the hypothesis and the conclusion of the converse. So, for an example, we'll go down to the table. The measure of angle A equals 15 degrees and is an acute angle. If the measure of angle A equals 15 degrees, then angle A is an acute angle. All right, is an acute angle. So the inverse, remember, is just not. If the measure of angle A, and if you want to, you can simply use symbols, not equal to 15 degrees, then angle A is not an acute angle. All right, that, ladies and gentlemen, hopefully you realize is false. A counterexample would be if the measure of angle A equals 20 degrees. It can still be acute. Okay, it can still be acute and not be 15 degrees. The converse, if angle A is an acute angle, then the measure of angle A equals 15 degrees. That is also false. That is also false. For the same reason, there's your counterexample. It usually works for both. And then the contrapositive is we're going to take the converse we just created. If angle A is not an acute angle, then the measure of angle A is not equal to 15 degrees. This one's true, and this one's also true. Are they all true? As a result, do they have the same truth value? The answer to that is a resounding no. All right? But instead of focusing on the negative, okay, let's focus on the positive, because we're positive people. Both the original conditional statement and the contrapositive true. This will always be the case. Now I need you to add something. Same truth value, because it's a little bit, I don't want to confuse people. So in other words, the original statement and the contrapositive will always have the same true value. So if one of them is true, the other one's true. If one of them's false, the other one's false. As a result, we say the original conditional and contrapositive are, here's another new phrase, All right, equivalent statements. And equivalent statements are simply two statements that always have the same truth value. All right. If it's October, then it is awesome. Awesome, huh? That would be true. The inverse, if it's not October, then it's not autumn. Again, counterexample like we mentioned in class 2.1. All right, could be November, could be September, could be December. December is part autumn, part winter. All right. The converse, if it's autumn, then it's October. Okay? Also false. Same counterexample. November, December, or September. Contrapositive, we're flipping and negating. So if it's not autumn, then it's not October. All right? Certainly true. All right? So the original and they're both true. And then the inverse and the converse are both false. Okay, the inverse and the converse are false. Geometric examples. If B is the midpoint of AC, then AB is congruent to BC. If B is the midpoint of AC, then AB is congruent to BC. That is certainly true. The contrapositive. If AB is not congruent to BC, then B is not the midpoint. All right. B is not the midpoint of AC. Certainly true. Okay, so they both are true. If ABCD is a square, then it is a quadrilateral. Certainly true. All squares are quadrilaterals. Quadrilaterals are defined as four-sided figures. So therefore, a square is a quadrilateral. All right. If we turn that around, if ABCD is not a quadrilateral, then ABCD is not a square. All right, so you'll see that they have the same truth values. So again, a conditional statement. The main thing is if then. Converse. We flip. The inverse. We add the words not to the original. And then again, the word of the day, contrapositive. What a great word. Contrapositive. All right, is both the inverse and converse. All right, I hope that helps with 2.2. Pretty soon we will post 2.3 and we'll be good to go. Have a good day.